times 10 to the power minus 3. Right. So we have calculated our radius of gyration. We go back to our equation. So what do we have? We know our area, right? We know our radius of gyration, right? So what do we don't know? We don't know what is our P. We don't know what is our E. We can find out what is our C. Okay, our C. So how to determine our C? Right. So the axis, let me copy this diagram again. It's important how we determine our C. Hold on. Okay. So next is to determine our C. Right. So if you look at C, right? C, so before we determine C, right, we have to see how our structure will, or which axis our structure will buckle. So we know that this is our X, we know that this is our Y, and we know that this is our Z. The axis that it will buckle, right, is this direction, right? So we know that this is our radius in the X. Okay. So the axis over here is critical now. So this is our x-axis. Okay. And we have to know, right, the bending moments, the stress, note the stress induced by the bending moment, right? We know that over here to get this, you have to have a bending moment, right? M is equal to 0 along the x-axis. Okay, so on this axis, along this axis, the normal stress is equal to 0. So the C direction is perpendicular, okay, to the axis, right? Furthest away, the distance furthest away, the maximum value. Okay, so therefore, for this case, C, right, is equal to what? 0.12, because it's 100 plus 100. So this entire distance is equal to what? 0.12, and then divided by 2 is equal to 0.06 meters. Okay. So yeah, I've seen a lot of students making mistakes regarding acquiring the value of C. Okay. Right. So once we have all these values, okay, let's see what we have. Okay. So we know what is our C, right? We don't know what is our P, and we also don't know what is our PCR. Okay, so we need to determine our P and PCR. Okay, our critical stress. Okay, so P is pretty straightforward. Right, P is equal to 130 times 10 to the power 3. Right, and because the definition of P is applied force, okay, then plus by 50 times 10 to the power 3. So this will total equal to 180 times 10 to the power 3 Newton. Okay. Then we are going to determine PCR. Okay, and PCR, so the next thing we have to find PCR, which is based on the extended Euler's formula, right? So the formula we're going to use is PCR is equal to pi squared E Ixx over LE squared. So by now, all of you should be very familiar with this formula already. Okay. So from here, we know that LE, we have LE is equal to what? So if we look at one end is fixed, the other end is pin. So we go to our diagram. One end is fixed, the other end is pin. So it's this one, right? So we are aware that one end is fixed, the other end is pin. So LE is equal to 0.7 times 6. So why 6? Because the height is 6. So 0.7 is equal to 4.2 meters. So now we can find our PCR is equal to pi squared. And our Young's modulus given to us as what? 200 times 10 to the power 9. Our Ixx is, we got it earlier, 6.9 times 10 to the power 6, or minus 6, divided by critical length, which is 4.2 squared. So I get 772, 772.112 times 10 to the power 3 Newton. So take note, PCR, I think I'm going to write this note. PCR for eccentric buckling is pi squared EI over LE squared. Okay. So for centric, the same formula. So I don't want you all to be confused regarding this matter. Okay. Right. So we have already determined our P and PCR. The next thing we don't know is our E. Okay. E is one thing that we don't know yet. Okay. Now this question is a bit tricky. Okay. Let me ask you, or let me tell you why. Okay. So now we are going to, let me get the diagram across. So the next thing we have to determine determine E, which is the eccentric distance. Okay. So the eccentric distance is relative to the centroid. Okay. Now I won't quite confusing, but now we have two loads. Okay. I repeat again. Now we have two loads. So what is this eccentric distance, right? So with that, so I'm going to sketch this out. So we know that this is our centroid. Okay. You know this position exactly over here. This is our centroid. Okay, so I'm going to sketch the axis or transformation. So this is Y, this is Z, this is rotation about X. So I'm going to take a moment, right, at this point over here. So I'm going to call this point A. Okay. So we are going to determine our moment about our x-axis at point A. And this will be equal to 130. Okay, so the first one is 130 times 10 to the power 3 multiplied by a distance of 0.12. And it's going anti-clockwise as positive. Then minus 50 times 10 to the power 3 multiplied by 0.08. So this will be equal to 130 power 3 times 1.12 minus 50 power 3 times 0.08 is equal to 11.6 times 10 to the power 3 Newton meter. So we know, right, that based on this configuration, right, we have a load of 11.6 times 10 to the power 3 Newton. So what we are trying to find is we are trying to determine, find E based from a single load. Okay. So what do I mean by a single load? Okay. So now if I'm going to sketch where point A is, okay, so this is at point A. Right. And then we have our centroid. So now we want to determine if this is our point A, and we know that there's a load coming down over here. Or yeah, there's a load coming down over here. And this load is going to be 130 times 10 to the power 3 plus by 50 times 10 to the power 3, which is equal to 180 times 10 to the power 3. Okay. What is this distance E, right? This is a E that will cause a moment about point A to be 11.6 times 10 to the power 3 Newton meter. Because E is a single value relative to the what? To the centroid. Okay. So from here, right, you can see that this is in Newton, this is in Newton meter. So we know that moment about X, right, at point A is equal to 180 times 10 to the power 3 multiplied by E. And we know that this is 11.6 times 10 to the power 3. And this will be equal to, let me write properly. So mx at point A, we should be determined, is equal to 11.6 times 10 to the power 3. And this is equal to 180 times 10 to the power 3 E. So finally, E is equal to 11.6 times 10 to the power 3 divided by 180 times 10 to the power 3. So 11.6. 180 is equal to 64.444 times 10 to the power minus 3 meters. Okay. We go for a break of 5 minutes. We come back in 5 minutes time.